Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating GitHub project, Lua-libuv, a lab for integrating Lua with Libuv for asynchronous scripting and POC experimentation. It's really cool.
Sounds interesting. What's the core idea behind this project? Is it just about running Lua scripts asynchronously?
Exactly. It's all about leveraging Libuv's asynchronous capabilities within a Lua environment. Think of it as a bridge, connecting the ease of Lua scripting with the power of Libuv for handling EO and other non-blocking operations. This allows for building efficient, responsive applications.
So how does the project structure facilitate this integration? I'm curious about the organization.
Right. The repo is neatly organized. It has dedicated folders for Libuv and Lua as submodules, external/Libuv and external/Lua, ensuring version control. The src/directory holds the custom C modules, which are then compiled and stored in modules/aud. The makefile manages the build process, making it easy to compile everything.
Clever. And what about the prerequisites? I imagine setting this up might be a bit involved.
It depends on your OS. On Windows, you'll need Visual Studio 2019. For Unix-like systems, you'll need GCC, Make, AutoTools, and libRedline. The RADME provides clear instructions for each. It's pretty straightforward once you have the right tools.
I see. The RADME mentions a makefile. What are some of its key functions?
The makefile is the heart of the build system. It handles updating submodules, building Libuv and Lua, compiling the custom C modules in src/she, and, importantly, has a clean target to remove build artifacts. It's a standard makefile, so anyone familiar with Make should be able to navigate it easily.
What about the Lua modules themselves? Are there any interesting examples included?
Absolutely. There's a modules/async.lua which demonstrates asynchronous operations using coroutines. It provides an await function, simulating asynchronous behavior within Lua. There's also a simple HTTP server example, server.lua, which uses a compiled C module for handling HTTP requests. It's a great illustration of the power of this integration.
That's a really practical example. So, the hello-world.lua file is just a basic test, right?
Precisely. Hello-world.lua is a minimal example showing how to load and use a custom C module, my_mod. It's a simple demonstration to verify the setup is working correctly. It's a great starting point for more complex projects.
This is fantastic. It seems like a great resource for learning how to integrate Lua with C and Libuv. What about contributions? Is the project open to contributions?
Absolutely. The project explicitly welcomes contributions. They encourage bug reports and improvements via pull requests. It's a collaborative effort, and it's great to see that kind of openness.
That's excellent. This Lua-libuv project seems like a valuable resource for anyone interested in asynchronous programming in Lua. It's well-structured, well-documented, and actively maintained.
Exactly. It's a fantastic example of how to combine the best of both worlds, the ease of scripting with Lua and the performance of asynchronous programming with Libuv. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into Lua-libuv. Goodbye, and happy coding.
Bye-bye.